Hi guys, in this video what we're going to do is we're going to prove that root 2 is irrational, and that basically means that we cannot write it in the form of p over q where p and q are integers. Okay, so what we're going to use a method that's called proof by contradiction, and what we're going to do is we're going to assume that root 2 is rational, and then the whole idea of proof by contradiction is we are then going to disprove this. So if it's not rational, then it must be irrational. So we're going to contradict this statement. That's what we're trying to do here. We use this quite a lot in maths. I'll give you another example at the end once I finish this. Okay, so we're assuming that root 2 is rational, and it can be written in the form that root 2 is equal to some fraction p over q. Okay, where p and q are integers, and it's in its simplest form. Now guys, this is the crux of this argument. So what we're saying is p and q have no common factors other than 1. So what I'm saying is that I can't say that we have a fraction, I'm just going to give you an example here, of 2 over 4, because that there is not in its simplest form. We know that 2 over 4 in its simplest form is equal to a half. So that statement here, where p over q is in its simplest form, is the important one here. This is the one that we're going to try and contradict. Okay, let's get on with the proof. So starting with root 2 is equal to p over q. The first thing I'm going to do is I'm going to square both sides to get rid of the square root. So if I do that, hopefully you can see what I now have is p squared over q squared is equal to, well, root 2 all squared just gets us to 2. And then the next thing I'm going to do, I'm going to take the q squared up to the left hand side here, so I'm going to multiply both sides by q squared. If I do that, I get 2q squared is equal to p squared. Now it doesn't matter what number you stick in for q, you can test this yourself if you want. If we multiply it by 2, it will always be an even number. So for example, q, if we let q equal to 3, 3 squared is 9, 9 times 2 is 18. So that's even. If I take an even number, 2, so 2 squared is 4, 2 times 4 is 8. Again, you can see that this is an even number. So this will always be an even number, which means that p must always be an even number. Because if you look at just 3 squared will be 9. That's not an even number. So I can't use the odd numbers. That means this must be even. 2 squared gives you an even number. 4 squared gives you an even number. 1 squared will give you a non-even number, i.e. an odd number. So because this has to be even, because it's got 2 times whatever this happens to be, that means that p squared has to be an even number. That means we can rewrite p as 2k, where k is just another variable that we've introduced, because if we multiply any number by 2, we're always going to get an even number. So we now have changed this to 2k squared, where k is just another number, and that is equal to, on the other side, 2q squared, as shown. Let's multiply it out. We get 2q squared is equal to 4k squared, and we can divide both sides by 2 to get q squared is equal to 2k squared. Now from here we can see that 2 is a factor of p squared, which means it's also a factor of p. And likewise here, 2 is a factor of q squared, which is also a factor of q. That means that what we have is a shared factor of 2, which means that our initial assumption at the beginning that we could write as p over q is not true, and therefore that means that this is not rational and is therefore irrational. So we can say, as p and q share a factor of 2, our original statement that root 2 is rational is false, therefore square root of 2 is irrational. Now I'd have a quick chat to you about another very basic form of, or somewhere we've seen this, and if you think about the formula or the test for two lines being perpendicular. So the perpendicular test is m1 multiplied by m2 is equal to -1. And suppose we had m1 is equal to 4/5, m2 is equal to 1/4. What we're doing is we're just seeing if it works. So we've got 4/5 times 1/4 is equal to -1. That's the statement that we are making if perpendicular. Okay. And all we do then, as you can see here, the 4 and the 4 cancel. We get 1/5 is not equal to -1. Therefore, by contradiction, these are not perpendicular lines. I.e., we have contradicted this statement here at the beginning.